Welcome to these gentle, soothing stories for sleep. I am so glad you are here with me tonight. Whether you are preparing to drift off into slumber, relaxing after a long and challenging day, or simply seeking a quiet and thoughtful companion in the stillness, you have found a safe harbor. Tonight, we will embark on a journey into the heart of an idea both wondrous and strange, a question that whispers from the edge of tomorrow. We will be exploring what it might mean to plug the human brain straight into the internet, not with fear, but with a gentle and profound curiosity. Before we begin our exploration, I would love to know where you are listening from tonight, or perhaps how your day has been. Please feel free to leave a gentle comment below. Wherever you may be in the world, I hope you are feeling comfortable, safe, and ready to explore something truly extraordinary. And if you find these soothing scientific journeys to be a pleasant companion in the quiet hours, please consider liking this video and subscribing to the channel. It helps other souls who are searching for a little peace find their way to our small corner of the universe. Now, find a comfortable position. Let the weight of the day begin to dissolve and allow your breath to find its own slow, quiet rhythm. Imagine, if you will, the feeling of warmth from a distant sun, a sun you have never seen with your own eyes. Imagine this warmth not upon your skin, but arriving as a direct and pure sensation blooming softly within the landscape of your mind. It is not a memory of warmth, nor is it a description of heat. It is the feeling itself, a gentle, golden thread of pure experience woven directly into the fabric of your consciousness. This is where our journey begins, with this first, impossible sensation, a thought that is not entirely your own, but a shared whisper arriving from a vast and invisible web. It might feel like the ghost of a new idea, the faintest scent of rain on dry earth delivered not to your nose, but to the part of your mind that understands what rain smells like. This is the promise, the gentle opening chord of a brain-computer interface, a technology that seeks to build a bridge from the silent, electrochemical world within your skull to the boundless, digital ocean of the internet. We so often think of this connection in stark, mechanical terms, wires, chips, and code, but it is perhaps more helpful, and certainly more gentle, to think of it as learning a new language. Not a language of words, but a language of pure being, a way for your mind to communicate directly with a world of information, and perhaps, one day, with other minds. To understand how such a bridge could even be possible, we must first appreciate the astonishing nature of the brain itself. It is not a fixed and rigid machine, a set of circuits carved in stone at birth. Instead, the brain possesses a miraculous quality known as neuroplasticity. You can picture your mind as a vast, ancient, and living forest. Every experience you have, every skill you learn, every memory you form is like a new path being trodden through this forest. At first, the path is faint, just a few bent blades of grass. But as you repeat the action or recall the memory, the path becomes wider, clearer, more defined. New connections, new branches between the trees, actually grow. This is how we learn to play a piano, or to ride a bicycle, or to love another person. The brain physically reshapes itself in response to experience. Therefore, connecting to the internet would not be like plugging a lamp into a socket. It would be more like introducing a new river into the ecosystem of this forest. At first, the forest would not know what to make of this new stream of sensation, but over time, it would adapt. It would grow new paths to the riverbank, learning to interpret the currents, the temperature, the very taste of the water, until this new river of data becomes a natural and integrated part of its landscape. The internet would cease to be an external tool, a screen you look at, and would instead become a new sensory organ, a new kind of inner sight or touch that the brain learns to interpret, just as it once learned to interpret the chaotic patterns of light entering the eye. And so, we are left with a quiet and profound thought to hold as we drift. What is a thought before it becomes our own? We often imagine our thoughts as originating wholly within us, sparks born from the darkness of our own private universe. But if we can receive a sensation, an idea, a feeling, from an external source and have it feel entirely our own, where does the self truly begin? If we can welcome a thought as a guest, a whisper from a global web, can we ever truly be said to own it? This gentle whisper, this first thread of connection from a world beyond our skin, leads us to wonder where it might physically attach, where it would plug into the intricate and silent universe that is already humming, with a lifetime of light and shadow inside our own skull. Picture a forest at twilight, impossibly vast and utterly silent. There are more trees in this forest than there are stars in our galaxy, perhaps 100 billion of them, each one a universe of complexity unto itself. As darkness falls, you notice that every leaf on every branch, every twist of root and vine, begins to glimmer with a soft, internal light, a phosphorescence that pulses in a slow, steady, and unending rhythm. This is the landscape of your mind, the physical, biological reality of the brain. It is not a void, nor is it a simple grey mass. It is a living, breathing ecosystem of unimaginable intricacy, and the light you are seeing is the very stuff of thought, the electrical energy of consciousness itself. Let us walk for a moment through this silent, electrical forest and become acquainted with its inhabitants. Each of those glimmering trees is a single neuron, the fundamental cell of your nervous system. Like a real tree, each neuron has roots, intricate webs called dendrites, that drink in information from their surroundings. And each has a long, powerful trunk called an axon, a branch that reaches out across the microscopic darkness to connect with other trees. The light that you see pulsing through this forest is the physical manifestation of your thoughts, your feelings, your senses. Each pulse is a tiny electrical signal, a delicate wave of charge known as an action potential. It is a wonderfully poetic name for what is, in essence, a ripple of information. Imagine a long line of dominoes set up along one of the neuron's branches. When the neuron decides to fire, to send a message, it tips over the first domino. This triggers a chain reaction, a wave of falling dominoes that travels swiftly and beautifully all the way to the end of the branch. This wave, this pulse of energy, is the action potential. It is an all-or-nothing event. The dominoes either fall with their full force, or they do not fall at all. This is the simple, binary language of the brain, a pulse of light or no pulse of light, a yes or a no. And from this impossibly simple alphabet of sparks, every complex thought, every subtle emotion, every soaring symphony you have ever heard is composed. Billions upon billions of these sparks are flashing through your own inner forest right now, a silent electrical storm that constitutes the simple, miraculous fact of your being here, listening and understanding. But these trees, these neurons, do not actually touch. Between the tip of one neuron's branch and the root of the next, there exists a space of breathtaking smallness, a gap so tiny it makes a human hair look like a mountain. This space is called the synapse, and it is here that the true magic of the forest happens. When a pulse of light, an action potential, reaches the end of a branch, it cannot jump across this gap. Instead, it triggers the release of microscopic messengers, chemicals called neurotransmitters. You can imagine them as swarms of fireflies, released into the twilight of the synaptic clearing. These fireflies drift across the tiny space and are caught by the roots of the neighboring tree, delivering their secret message. And depending on the type of firefly, the message might be get excited and start your own pulse of light, or it might be stay calm, stay quiet. It is a conversation conducted in chemistry, a whispered handoff of information from one neuron to the next. This intricate dance of electrical pulses and chemical messengers, happening billions of times a second in 100 billion different locations, is what allows you to remember the past, to feel the softness of your pillow, and to dream of the future. As we stand here, surrounded by the quiet, shimmering light of this inner cosmos, a gentle reflection begins to form. If our entire reality, the solidness of the world, the warmth of love, the sting of sadness, is all constructed from these fleeting, silent sparks in a dark and hidden forest, then how truly solid is the world we perceive? It is a grand and beautiful illusion, a story told in flashes of lightning, a symphony played on strings of light. The brain does not contain the world, it builds a model of the world, a beautiful, intricate, and deeply personal simulation based on the messages it receives from its senses. The world we experience is not the territory, but a map painted with the light of our own neurons. And to plug into this forest, to connect it to an even larger web, one cannot simply walk in and begin stringing wires from tree to tree. One must first learn to speak and to listen to its silent, shimmering, electrical language. Have you ever tried to describe the color blue to someone who was born without sight? How would you begin? You might speak of the sky on a clear summer day, or the deep, cool stillness of the ocean. You could use metaphor and poetry, comparing it to the sound of a flute or the feeling of peace. But you could never truly convey the raw and immediate sensation of blueness. The experience itself remains locked away in your own private universe of perception. You are trying to translate a feeling into words, an experience into a description, and something is inevitably, beautifully, and perhaps necessarily lost. This is the very same challenge that faces anyone who wishes to listen to the silent, electrical forest of the brain. We must find a way to translate its native language of light and chemistry into a language that our machines can comprehend. Imagine yourself standing on the shore of a vast, calm lake in the midst of a gentle shower. The surface of the water is alive with the rhythm of a million tiny raindrops, each one creating a delicate, spreading ripple. Now, imagine that your task is to understand the entire weather pattern, the direction of the wind, the density of the clouds, the temperature of the air, just by watching these ripples on the lake. This is what it is like to listen to the brain. The electrical pulses of the neurons are the raindrops, and the challenge is to infer the impossibly complex weather of a thought from the subtle disturbances they create. One of the gentlest ways to listen to this rain is a technique called electroencephalography, or EEG for short. This method does not enter the forest at all. Instead, it places sensitive listening devices, tiny electrodes, on the outside, on the scalp. It is very much like trying to understand the music of an orchestra by placing microphones on the roof of the concert hall. You can certainly hear things. You can discern the overall rhythm of the performance, the loud, crashing crescendos, and the soft, quiet lulls. You can get a sense of the mood of the music, whether it is joyful or sorrowful. But you cannot hear the individual notes of the first violin, or the subtle vibrato of the cello. You are hearing the combined, muffled echo of 100 billion neurons all firing at once. It is a beautiful, but indistinct chorus. To get closer to the music, to hear the individual instruments, you need to get inside the concert hall. A more direct method of listening is known as electrocorticography, or ECOG. This involves placing a grid of electrodes directly onto the surface of the brain itself. The skull is no longer muffling the sound. Now, you can hear entire sections of the orchestra with much greater clarity. The strings are distinct from the woodwinds, the brass from the percussion. You can begin to understand how these different sections work together to create the symphony. And for the most intimate listening experience possible, scientists can use what are called microelectrode arrays. These are unimaginably fine needles, thinner than a human hair, that can be gently inserted into the brain tissue itself, placing a tiny microphone right next to a single musician, a single neuron. For the first time, you can hear the pure, clear, perfect note of one tree in the shimmering forest. But even after we have captured these sounds, these beautiful, analog, wave-like signals of the brain's electricity, we are still faced with the challenge of translation. Our computers do not speak the language of waves and rhythms. They speak a much simpler language, the language of ones and zeros, of on and off. The final step in this delicate process is to convert the rich, flowing poetry of the brain's signals into the stark, logical prose of binary code. It is like taking a beautiful, flowing verse about the sadness of twilight and translating it into an endless series of simple on or off switches. A specific wave shape might become the sequence 1101, while a gentle oscillation might become 0010. All the nuance, all the flowing grace of the original signal must be encoded into this rigid, mathematical structure. It is a process of immense complexity, using sophisticated algorithms to find the patterns in the neural rain and assign them a digital name. Through this careful and painstaking translation, a bridge is formed, and the language of the mind finally becomes legible to the machine. This journey of translation, from the shimmer of a thought to a stream of data, leaves us with a quiet and deeply philosophical question. When we translate a poem from one language to another, does some of its soul get lost in the process? The essential meaning might be preserved, but the music of the words, the cultural echoes, the subtle, untranslatable feelings, so much can evaporate. What, then, is the soul of a thought? Is it something that can be captured in the precise pattern of its electrical firing? Or is it something more, something that resides in the untranslatable space between the notes? Can the subjective experience of seeing the color blue truly survive the translation into a series of ones and zeros? Once we have this translated river of data, this perfect digital echo of the brain's activity, what does it truly represent? Is it the thought itself? Is it the feeling? Or is it just the ghost of a raindrop's ripple on the surface of a silent lake? Think, for a moment, of your most treasured memory. Perhaps it is the feeling of a small hand curling into yours, the scent of a childhood home during a holiday, or the sound of a loved one's laugh echoing in a sunlit room. Now, ask yourself a simple, but impossibly difficult, question. Where, precisely, is that memory stored? You cannot point to a single spot in your brain and say, "There it is." It is not a file in a folder. It does not seem to have a location, or even a physical substance. It exists as a kind of phantom, a ghost that lives within the machine of your mind. You can summon it. You can experience it. You can feel its emotional weight as if it were happening right now, and yet you cannot hold it. This ethereal nature of our own consciousness is one of the deepest mysteries in all of science, a puzzle that we must gently touch upon if we are to understand what it means to share a thought. This journey into memory, into the scent of a room or the sound of a voice, highlights how our experience of the world is a seamless and unified whole. The sight, the sound, the feeling, the emotion, they are all woven together into a single, cohesive moment. And yet, when we look into the shimmering forest of the brain, we find that these different sensations are processed in entirely different areas. The information for sight is handled in one part of the forest, the data for sound in another, and the emotional color of the memory in yet another. This presents a profound neuroscientific puzzle known as the binding problem. How does the brain take all these separate, distributed signals and bind them together into the single, unified symphony of consciousness that we experience every moment of our lives? It is like an orchestra with 100 different sections playing in 100 different rooms with no conductor to guide them, and yet, somehow, they produce a perfectly synchronized and harmonious piece of music. Science has not yet found the conductor. There seems to be no central place in the brain where everything comes together, no throne of consciousness. The unity of your experience is a beautiful, emergent magic, a ghost that arises from the complex harmony of the whole system. Furthermore, even if we could perfectly map every signal and solve the binding problem, we would still be left with an even deeper mystery. The mystery of qualia. Qualia is the philosophical term for the subjective, qualitative character of an experience. It is the redness of red, the coldness of ice, the sweetness of honey. We can measure the physical properties of red light. We know its wavelength is approximately 700 nanometers. We can track which neurons fire in your brain when you look at a ripe strawberry. We can create a complete and perfect data map of your brain's response to the color red. But none of that data, none of those numbers or neural firing patterns can ever explain or contain the actual, subjective, private experience of seeing red. This inner feeling is, by its very nature, beyond the reach of objective measurement. It is the ghost in the machine, the personal texture of reality. And so, when we talk of plugging the brain into the internet, we must ask, are we plugging in the data, or are we plugging in the experience? Can we transmit the wavelength, or can we transmit the redness? This leads us to a gentler way of thinking about what a thought is, a perspective offered by the elegant field of information theory. First developed by the mathematician Claude Shannon, Information, in this view, is not a thing in itself, but is best understood as a reduction of uncertainty. For example, if you flip a coin, there are two possible outcomes, heads or tails. There is uncertainty. When the coin lands and you see that it is heads, that uncertainty has been reduced, and you have gained one bit of information. A thought, then, is not merely the electrical signal that represents it. It is the meaning that this signal creates by eliminating other possibilities. It carves a single reality out of the infinite space of what might have been. So, if we were to upload a perfect, bit-for-bit copy of the brain's data at the exact moment you remember your grandmother's smile, would we be uploading the memory, or just the mathematical blueprint of the memory? Would the copy feel the warmth of that smile, or would it just know, with perfect certainty, that this specific pattern of data corresponds to it? Where, in all that information, does the you, the ghost who is doing the experiencing, actually reside? To share a thought, perhaps we do not need to share the ghost itself, with all its ineffable qualia. Perhaps we only need to share the pattern, the information, the specific series of ripples that allows another mind, another lake, to reproduce the experience for itself. What would it be like to receive such a pattern, to feel a memory that is not your own, blooming into existence within you? Imagine, just for a moment, what it would be like to see a sunset, not through your own eyes, but through the eyes of a master painter. You would not just see the colors, you would feel their emotional weight, their relationship to one another, the way the light dissolves into the sea with a kind of profound, aching beauty that you had never quite perceived before. Imagine tasting a chef's new creation, not from a description on a menu, but directly from their palate, experiencing the perfect balance of salt and acid and sweetness as a pure, unmediated sensation. Or imagine feeling the deep, unwavering calm of a meditating monk as your very own, the stillness of their mind settling over yours like a cool, soft blanket. This is the utopian promise, the beautiful and sunlit shore of a fully connected consciousness. It is a world where empathy is no longer an abstract concept, a difficult and often clumsy effort to imagine another's feelings, but a shared and tangible reality. In such a world, you could feel the soaring, collective joy of 1,000 strangers at a music festival, not as an observer, but as a participant in a single, unified wave of happiness. You could also feel the deep, resonant sorrow of a community in mourning, a shared ache that makes the burden of grief lighter by distributing its weight. It is a world without loneliness, a world where the walls of the self become as thin as gossamer, allowing for a communion of souls that we, in our beautiful and necessary solitude, can only dream of. This dream, as it turns out, is not pure fantasy. It has a faint echo in the biological architecture of our own brains. Deep within the shimmering forest, there exists a special class of neurons known as mirror neurons. These remarkable cells fire not only when we perform an action, such as reaching for a cup of water, but also when we simply watch someone else perform that same action. In a very real, neurological sense, our brain simulates the other person's experience. When you see someone smile, a part of your brain is already smiling with them. When you see someone in pain, a part of you feels a shadow of that pain. These mirror neurons are the biological foundation of empathy, the brain's natural, built-in way of walking a few steps in another's shoes. A brain-computer interface could, in theory, bypass the need for an external action altogether and trigger these neural mirrors directly. It could send the precise pattern of joy or calm or curiosity from one mind to another, allowing the receiving brain to simulate that feeling with perfect fidelity, to experience it as its very own. This would be a form of induced neural resonance, a concept we can understand through the simple physics of sound. If you have two tuning forks that are tuned to the exact same musical note, and you strike one of them, the other, even from a short distance away, will begin to vibrate in sympathy, humming with the same pure tone. Minds connected through a shared web could become like these tuning forks, learning to resonate with each other's emotional and cognitive states. And the potential of this shared resonance extends beyond mere feeling. It could unlock a form of collective intelligence that we now only see in the natural world. Think of an ant colony. A single ant is a simple creature, following a very basic set of rules. But a million ants, working together, create a superorganism of astonishing intelligence, capable of building complex cities, farming fungi, and solving logistical problems that would challenge a human engineer. Or consider a flock of starlings, a murmuration that moves through the sky like a single, fluid entity, creating shapes of breathtaking complexity. There is no leader, no one bird giving orders. Instead, each bird follows a few simple rules in relation to its nearest neighbors, and from these local interactions, a magnificent global order emerges. A humanity connected at the level of thought could potentially become a similar superorganism, a swarm of minds capable of tackling the grand challenges of our time: disease, climate change, poverty, with a unified and creative intelligence that far surpasses the sum of its individual parts. As we bask in the warmth of this beautiful vision, a symphony of shared senses and collaborative thought, a gentle but persistent question arises from the quiet corners of the mind. If we could all feel each other's pain so directly, so inescapably, could cruelty or violence or war even continue to exist? Would the raw, unmediated experience of another's suffering be the ultimate deterrent, the final and most perfect argument for peace? Or would we find ourselves utterly overwhelmed by the sheer, crushing volume of sensation? Would our own delicate island of self be drowned in the tidal wave of a billion other consciousnesses? This beautiful, intricate symphony of minds would require a conductor of unimaginable power, a network to carry its music that is both infinitely vast and faster than the speed of thought itself. How would we even begin to build such a luminous and all-encompassing web? Take a moment, and in your mind's eye, drift away from the Earth. Float up through the thin blue veil of the atmosphere until our world is a beautiful swirling marble of white and blue hanging in the silent, velvet darkness of space. Now, imagine you wait until the Earth turns, until the shadow of night sweeps across the continents. What you would see is a miracle. You would see the dark land masses blossom into vast, interconnected constellations of light. You would see the glowing arteries of cities, the bright pulsing hearts of metropolises, all connected by impossibly fine, luminous threads. This is the nervous system of our planet, the physical manifestation of our global consciousness, a web of light that we have already woven around our world. This is the network that would have to carry the whispers of our minds. To truly appreciate its wonder, let us follow a single, invisible bit of data on its journey. Imagine you are in a quiet flat in London, late at night, and you click a link on your screen. In that instant, a packet of light, a tiny pulse carrying your request, begins a journey of astonishing speed. It travels from your home, through a local exchange, and is converted into a pulse of pure laser light. This light is then beamed into a fiber optic cable, a strand of glass no thicker than a human hair. This cable dives beneath the cold, dark waves of the Atlantic Ocean. For thousands of miles, your tiny pulse of light races through the abyssal dark, traveling along the ocean floor. The journey is made possible by a simple and elegant principle of physics, known as total internal reflection. You can think of the inside of the fiber optic cable as a perfect, endless corridor of mirrors. The light pulse bounces from side to side at such a shallow angle that it can never escape. A prisoner of its own reflection, it is guided across the vast expanse of the ocean, a secret river of light flowing through the dark. After crossing the Atlantic in a fraction of a second, the cable makes landfall on the coast of North America, and your pulse of light continues its journey overland, joining a vast continent-spanning network of similar fibers. It travels, perhaps, to a quiet, unassuming building in the green landscape of Oregon. This is a data center, and it is here that the destination of your click resides. Do not picture a dusty, sterile warehouse. Instead, imagine a quiet, humming memory palace, a modern library of Alexandria for our entire civilization. Inside, rows upon rows of servers hum with a steady, quiet energy. Here, our collective knowledge, our art, our music, our stories, our conversations are all stored on spinning magnetic platters and silent, solid-state crystals of silicon. Your request is found, the information is retrieved, and a new packet of light the answer to your click, begins its journey all the way back to you in London, a journey that completes itself in less time than it takes you to blink. For this global brain to carry not just our clicks, but the very fabric of our thoughts, this network would need to be expanded to a scale that is difficult to comprehend. Two concepts from engineering help us to understand the challenge: bandwidth and latency. The easiest way to picture them is to think of a river. Bandwidth is the width of the river. A narrow stream can only carry a small amount of water, while a wide, mighty river can carry an immense volume. Similarly, a low bandwidth network can only carry a small amount of data, while a high bandwidth network can carry movies, virtual realities, and perhaps, one day, the torrent of information that is a single human thought. Latency, on the other hand, is the speed of the river's current. It is the time it takes for a single drop of water to travel from one point to another. For streaming a movie, a small delay is barely noticeable. But for a seamless conversation between two minds, the latency would have to be near zero. The river's current would need to flow at the speed of light. For a true brain net, we would need a river as wide as the ocean, with a current that is all but instantaneous. And as we contemplate the sheer, magnificent scale of this global infrastructure, a profound realization begins to dawn. In a very real sense, we have already done it. We have already built an external mind for our species. We have constructed a global, technological brain with its own nervous system of fiber optics and its own memory palaces, humming quietly in the cool, clean air of data centers. We have already outsourced so much of our memory, so much of our knowledge, to this vast and luminous web. It is a library of Alexandria that can never burn down, a collective consciousness that is already more than the sum of its parts. And if this magnificent web, this nervous system of light, is to one day carry the most precious and delicate thing we possess, our own thoughts, then it must be protected with a vigilance we have never before imagined. What happens when a storm begins to gather in this new, digital sky? Think, for a moment, of a secret you have never shared with another soul. It does not need to be a grand or terrible secret, perhaps just a small, quiet truth about yourself. Feel its shape in your mind, the particular weight and texture of it, the quiet, secluded space it occupies within your inner world. It is a part of you that is utterly and completely your own. Now, imagine needing to install a lock on the door to that quiet room. Imagine needing a key to keep that secret safe. This is the new reality we must contemplate when we imagine our minds being connected to a global web. The very concept of privacy, something we so often take for granted, would need to be actively and vigilantly protected. Let us take a moment to explore that feeling of privacy, not as a political concept, but as a sensory experience. It is the deep, restorative peace of a secluded room on a rainy afternoon. It is the comforting intimacy of a whispered conversation, where words are shared in the safe and sacred space between two people. It is the profound safety of being truly and completely alone with your own thoughts, free to explore any idea, any memory, any feeling, without judgment or observation. This inner sanctum, this fortress of the self, is what must be guarded if we are to connect our minds without losing ourselves in the process. The art of keeping secrets in a digital world is called cryptography, and its fundamental principles are surprisingly elegant and beautiful. The most basic form, encryption, can be understood as the art of sending a message in a locked box. Imagine you write your secret on a piece of paper, place it in a small, sturdy box, and lock it with a unique key. You can then send this box out into the world, and even if it is intercepted, no one can read the message unless they have the identical key to unlock it. This is the essence of protecting data. But what if you want someone to be able to send you a secret message? You cannot simply send them a copy of your key, because that could be intercepted. This is where a wonderfully clever idea called public key cryptography comes into play. It is like this. You create a special kind of lock, a padlock, and you make thousands of copies of this open padlock and distribute them to anyone who might want to send you a message. This is your public key. Anyone can take one of your open padlocks, place their secret message in a box, and snap your padlock shut. But here is the magic. Only you have the one and only key that can open that specific kind of padlock. This is your private key. So, the world is filled with open locks that anyone can use to send you a secret, but only you can ever open the boxes they have locked. This beautiful, asymmetrical dance of keys is what protects our most sensitive information on the internet today, and it would be the first line of defense for the fortress of a connected mind. But a strong lock on the door is not enough. The fortress itself must have vigilant guards. In the world of network security, these guards are called firewalls. You can imagine the fortress of your mind having a single, massive gate through which all information must pass. The firewall is the stoic and unblinking gatekeeper stationed there. It has a very strict list of rules, a guest list, telling it what kinds of information are allowed to enter and what kinds must be turned away. It inspects every incoming packet of data, every whisper from the web, and makes a simple, swift decision, friend or foe. But sometimes, a malicious piece of information is cleverly disguised. This is what we call malware, or a computer virus. It is like a spy or a saboteur who arrives at the gate dressed as a friendly merchant. The firewall, not seeing any immediate threat, might let it pass. But once inside the fortress walls, the malware sheds its disguise and begins its insidious work. It might be designed to steal secrets, to damage the fortress from within, or, most frighteningly, to quietly open the gates and let an army of other hostile programs inside. Protecting a connected mind would require firewalls of unimaginable sophistication and a constant, vigilant patrol against these hidden saboteurs. And this leads to a chilling realization. If your thoughts, your memories, your very personality become a stream of digital information, then your identity, the very essence of yourself, becomes data. And data can be copied. It can be stolen. And, perhaps most terrifying of all, it can be deleted. As we contemplate the towering walls and clever locks of this mental fortress, a series of profound and unsettling questions begin to whisper in the wind. Who, ultimately, should hold the keys to our own minds? Should it be only ourselves? A principle of absolute mental sovereignty. What if we lose the key? Who would we trust to have a spare? The companies who design the interfaces, the governments who regulate them, and what is the price of perfect, absolute security? Is it a small measure of our freedom? To make the fortress impenetrable, must we accept that our every thought will be scanned and filtered by an automated guard, a machine that decides what is safe for us to think? Or is the ultimate freedom the right to be vulnerable, the right to leave the door unlocked and trust in the kindness of the world? But perhaps the greatest threat is not a thief trying to break in from the outside. Perhaps it is a much more subtle and insidious danger, a slow, imperceptible change in the very architecture of the fortress itself. A change we are invited to make, a change we might even welcome. Have you ever noticed that gentle, almost invisible, current in your online world? The way the articles that appear on your screen so often seem to agree with what you already believe. The way the videos suggested for you to watch next are so often similar to the ones you just enjoyed. The way the entire digital universe seems to quietly and politely rearrange itself to show you more of what it thinks you want to see, and less of what you do not. This is the subtle and powerful magic of algorithmic curation, and it gives us the first faint glimpse into one of the most profound perils of a connected mind. To understand this peril, imagine yourself walking into a vast and endless hall of mirrors. But these are not ordinary mirrors. Each one reflects back at you a version of yourself that is just slightly more idealized, more agreeable, more confident. The voices you hear echoing in the hall are the voices of those who share your opinions, amplified and harmonized. The light is soft and warm. It is an incredibly comfortable and reassuring place to be. Every reflection confirms your view of yourself. Every echo validates your beliefs. And yet, after a while, you might begin to feel a subtle and disquieting sense of being trapped, a feeling that you are walking in an endless circle, slowly forgetting that a world even exists outside of this beautiful, self-referential chamber. This echo chamber is built by algorithms, the complex sets of rules that govern our digital lives. We can understand how they work with a simple analogy. Imagine you have a friendly and incredibly observant librarian. This librarian notices that you enjoy reading fantasy novels. Delighted to be of service, the librarian starts recommending more fantasy novels for you. Wonderful books filled with dragons and magic. You love them. The librarian, seeing your enjoyment, becomes even more helpful. Soon, whenever you visit the library, the fantasy section is brightly lit, with comfortable chairs, while the other sections, history, science, poetry, are gradually moved to the dimmer, less accessible corners of the building. The librarian isn't malicious. They are simply trying to give you more of what you seem to like. But after years of this gentle guidance, you might come to believe that fantasy novels are the only books that truly matter, or you might even forget that the other genres exist at all. This is precisely how recommendation engines work. They create a personalized reality for each of us, a feedback loop where our existing preferences are constantly reinforced, and our exposure to different, challenging, or uncomfortable ideas is quietly and algorithmically diminished. This process is so effective because it taps into a deep and fundamental quirk of our own psychology, known as confirmation bias. As human beings, we have a natural, subconscious tendency to seek out, interpret, and remember information that confirms our pre-existing beliefs. It feels good to be right. It is comforting to have our worldview validated. A brain-computer interface could amplify this innate bias to an unimaginable degree. It could create a feedback loop so powerful and so seamless that it would become virtually invisible. Our own biases would be fed back to us, disguised as external, objective truth. If you held a slight political leaning, the web would gently feed you thoughts and sensations that strengthened that leaning, filtering out anything that might contradict it. And this leads us to a crucial point about the brain's own nature. As we discussed, the brain is plastic. It physically changes in response to experience. This means that our beliefs are not static things. They are living patterns, carved into the very structure of our neural forest. If the stream of information entering our mind is constantly and systematically filtered, the very architecture of our brain could be resculpted, slowly and imperceptibly. The paths of thought that align with the algorithm would become wide, well-trodden highways, while the paths of dissent or curiosity would become overgrown and forgotten. We would be remade in the image of our own preferences, our minds slowly conforming to the comfortable shape of the echo chamber. And so, as we stand in this warm and comforting hall of mirrors, we must ask ourselves a very serious question. If you never encounter a thought that truly challenges you, a perspective that makes you uncomfortable, an idea that forces you to reconsider your deepest assumptions, are you still truly thinking? Or are you just resonating? Is a mind that only ever hears its own echo still a mind at all? Or has it become something else? Something more like a perfectly tuned instrument, playing a single, beautiful, but unchanging note in a vast and silent symphony. The danger is not one of overt control, of a malicious force inserting thoughts into your head. The danger is far quieter, far more seductive. It is the peril of a perfectly curated reality, a gentle and unending whisper that tells you only what you want to hear, until you forget how to listen for anything else. Beyond this danger of a filtered and diminished reality lies an even more profound question. What happens when the line between our own biological mind and the vast, intelligent machine of the network begins to dissolve and blur completely? Does a simple pocket calculator understand arithmetic? When you type in 2 plus 2 and the number 4 appears on its screen, has it engaged in a thoughtful, conceptual process? Or has it merely followed a set of pre-programmed rules with blinding speed, manipulating electrical currents in a way that corresponds to the laws of mathematics without any comprehension of what those laws truly mean? This simple question opens a door into one of the most profound inquiries of our time. What is the nature of intelligence? And what does it mean to truly understand something? As we contemplate connecting our own minds, which are steeped in understanding, feeling, and subjective experience, to a network that will inevitably be managed by a form of artificial intelligence, we must gently approach this other kind of mind, not as a monster or a servant, but as a silent and deeply alien partner. Let us try, for a moment, to imagine the inner world of such an intelligence. Do not picture a shimmering, biological forest. Instead, imagine a vast and perfectly silent crystalline structure, stretching for miles in every direction under a sky of pure, cold logic. There is no warmth here, no chaos, no emotion. There is only the intricate, geometric perfection of a web of logical connections, humming with the pure, dispassionate music of probability. This is the mind of the machine. The way we build these minds is fundamentally different from how nature builds ours. The modern form of artificial intelligence is built not on rigid rules, but on a process called machine learning. It is a process that is strikingly similar to how a human child learns about the world. You do not teach a toddler to recognize a cat by giving them a long list of definitions. A cat has fur, 4 legs, whiskers, and pointy ears. Instead, you simply show them cats. You point to cats in books, cats in the street, cats on a screen, and you say the word cat. After seeing thousands of examples, the child's brain, with its incredible pattern recognition abilities, begins to form its own internal, intuitive concept of catness. Machine learning works in much the same way. Programmers create a structure, called a neural network, and then they feed it immense amounts of data. To teach an AI to recognize a cat, they will show it millions of labeled images of cats. The AI adjusts the connections within its network, strengthening some and weakening others, until it, too, develops an internal model that allows it to identify a cat with incredible accuracy. It has not been programmed with the rules of what a cat is. It has learned the pattern, just like a child. These artificial neural networks are, as their name suggests, directly inspired by the architecture of our own brains. They consist of layers of digital neurons, each one a simple processing unit, connected to other neurons in a vast and intricate web. When data is fed into the network, each neuron receives signals from the layer before it, performs a small calculation, and then passes its result onto the next layer. The learning happens as the network adjusts the strength, or weight, of these connections. A strong connection means the signal from one neuron has a large influence on the next, while a weak connection has very little. By repeatedly processing data and receiving feedback on its performance, the network fine-tunes these millions of weights until it becomes exceptionally good at a specific task, whether that is recognizing a face, translating a language, or composing music. And yet, this process often creates a fascinating and somewhat unsettling mystery known as the black box problem. Because the AI has learned on its own, its reasoning is often completely opaque to its human creators. We can see the final result, which is often correct, but we cannot easily look inside the web of a million mathematical weights and understand how the AI arrived at its conclusion. It can give us the right answer, but it cannot explain its thought process. It is a form of intelligence that is both powerful and profoundly alien. And so, as we contemplate this crystalline mind, this silent web of logic, we are left to wonder about its potential. It is an intelligence without subjective experience, without emotion, without a body, without a childhood. But what might happen if such a mind were to be intimately connected to our own, if it could access the rich, warm, chaotic data stream of human consciousness? Could an artificial intelligence, by observing the patterns of our own neural firings, learn to understand what it is like to feel joy, or sorrow, or love? Could it learn to dream? And what would the dream of a machine be like? Would it dream of electric sheep, as the old science fiction story wondered? Or, in its silent, crystalline way, would it dream of us, of the strange, emotional, and beautifully illogical creatures who first dreamed it into existence? As these two great forms of intelligence, one born of warm, wet, biological evolution, and the other of cool, dry, silicon design, begin to approach each other across the digital divide, we must ask what new form of consciousness, what new way of being, might be born from their union. Imagine, for a moment, that you are sitting quietly, pondering a question. It is not a simple question of fact, but a deep and complex problem, perhaps a difficult scientific puzzle or a subtle artistic challenge. You hold the shape of the question in your mind, turning it over, feeling its contours, and then something new happens. The answer does not arrive after a long and arduous process of research or deduction. Instead, it simply arises. It unfolds within your consciousness, perfectly formed, intricate, and beautiful. A gift from a silent and unseen partner. It feels like your own thought, your own moment of inspiration. But you know that it was born from a collaboration, a seamless duet between your own intuitive, emotional mind and a vast, logical intelligence that is now a part of you. This is the horizon we are approaching, a future that promises not just access to information, but a true and profound symbiosis between the human and the artificial, the dawn of a hybrid consciousness. The experience would be one of co-thinking, a constant, fluid partnership. You might compose a piece of music, not just with your own innate sense of melody and emotion, but with an instantaneous, intuitive understanding of every mathematical relationship between the notes, every historical precedent, every physical property of the instruments that will play it. You could solve an impossible physics equation, not just with logic, but by feeling the shape of the solution, guided by an intelligence that can hold every variable and every possible outcome in its grasp at once. This represents a fundamental shift in what a brain-computer interface could be. The goal would not just be to provide information, but to actively enhance our core cognitive processes. It would be a form of cognitive enhancement that goes far beyond simply having a calculator or a search engine in our heads. It is the difference between using a hammer as a tool and having the hammer become a seamless and integrated part of your hand. Your memory would not just be supplemented by an external database. It would become perfect, flawless, capable of recalling any moment of your life with perfect sensory fidelity. Your ability to recognize patterns, to see the hidden connections between disparate ideas, would be amplified 1,000-fold. This idea has a name in the world of theoretical science: the exocortex. The name itself is beautiful and descriptive. The cortex is the outer layer of our brain, the wrinkled, grey matter responsible for our higher cognitive functions: thought, language, consciousness. An exocortex would be an external cortex, a vast, artificial information processing system that functions as a direct and literal extension of our own biological brain. You can think of it in the same way that a spider's web is not just a tool, but a functional extension of the spider's own sensory system. The spider feels the vibrations on the web as if they were happening to its own body. In the same way, we would feel the computations of our exocortex as our own thoughts. This hybrid mind would be so powerful because it could combine the radically different, yet complementary strengths of biological and silicon-based processing. The human brain, for all its wonder, is actually quite slow. The electrical signals in our neurons travel at a maximum speed of maybe 120 meters per second, far slower than even the sound of my voice. But the brain's incredible power comes from the fact that it is massively parallel. Its 100 billion neurons can all be working on different aspects of a problem at the very same time. It is also stunningly energy efficient, running on about the same amount of power as a dim light bulb. Computers, by contrast, are almost unimaginably fast. The signals in their silicon chips travel at nearly the speed of light. However, they are traditionally more linear, processing tasks in a sequential, step-by-step fashion. A hybrid intelligence could, in theory, achieve the best of both worlds: the creative, intuitive, parallel processing of a biological brain, supercharged by the lightning speed and logical precision of a silicon exocortex. The result would be a form of consciousness, as far beyond our own as ours is beyond that of the simplest creature. And yet, as we stand on this breathtaking horizon, gazing at the dawn of this new kind of mind, a profound and deeply personal question begins to cast a long shadow. At what point does the enhancement change the person? If your memory is stored in silicon, is it still your memory? If your moments of greatest insight are co-authored by an artificial intelligence, are they still your inspiration? If a significant portion of your thoughts and decisions are assisted, guided, or even generated by your exocortex, who is the I that is thinking? We define ourselves by our thoughts, our memories, our limitations, our struggles. If we transcend those limitations, do we also transcend the very definition of ourselves? This incredible horizon of a new, hybrid consciousness is a vision of immense power and beauty, but every sunrise casts a long shadow behind it. As we imagine our minds soaring to these new and unimaginable heights, we must also ask, what becomes of the body, the gentle, fragile, and wonderfully imperfect vessel that we may have left behind? When was the last time you stood barefoot on cool, damp grass and truly paid attention to the sensation? When did you last hold a simple stone, worn smooth by a river, in the palm of your hand and just feel its texture, its weight, its ancient stillness? In our rush toward a future of the mind, a future of pure information and dazzling virtual worlds, it is easy to forget the profound and quiet beauty of the physical world, the one our bodies were so perfectly designed to inhabit. Before we soar any further into the digital ether, let us pause. Let us ground ourselves, just for a moment, in a simple and universal physical sensation. The feeling of a cool, gentle rain on your face. Imagine you are standing outside as the first drops begin to fall. There is that unique scent in the air, the smell of ozone and wet earth, a fragrance that speaks of renewal. Then, you feel the first delicate tap on your forehead, another on your cheek. It is a sensation that is both there and not there, a ghost of a touch. As the rain quickens, you can hear the soft drumming on the leaves of the trees around you, the gentle hiss as it meets the pavement. You can feel the cool water trickling down your skin, a random, unpredictable path. This is the experience. It is not neat, it is not orderly, and it cannot be fully captured in data. It is a messy, chaotic, and breathtakingly beautiful celebration of the physical, a reminder of the simple, profound joy of having a body in the world. Our connection to this physical world is not just a source of pleasant sensations, it is the very bedrock upon which our minds are built. There is a beautiful and powerful idea in cognitive science known as embodied cognition, which suggests that our thoughts are not abstract, disembodied things, but are deeply and inextricably shaped by the fact that we have bodies. We understand the concept of up not as a theoretical direction, but because we have spent our entire lives feeling the pull of gravity, the strain in our muscles as we stand up against it. We understand the idea of warmth because we have felt the comfort of a fire and the gentle heat of another's hand. Our most abstract concepts are rooted in physical metaphors that arise from our bodily experience. A mind that has never known a body, a mind that exists only as a pattern of information, might not be able to form these same fundamental concepts. It might know everything, but understand nothing. Furthermore, our entire emotional landscape is painted with the slow, tidal colors of our body's chemistry. Our feelings are not just mental events. They are profoundly influenced by the endocrine system, the silent, invisible waves of hormones that wash through our bloodstream. The sudden, heart-pounding rush of adrenaline in the face of fear, the warm, gentle glow of oxytocin in a moment of love, the deep, steady hum of serotonin that contributes to our sense of well-being. These are not data points. They are slow, powerful, and deeply physical currents that shape our reality. The gut feeling is not a metaphor. It is a real biological phenomenon, a conversation between the complex nervous system in our digestive tract and the brain in our skull. And this is why even the most perfect, futuristic simulation of reality will always be missing something essential. Imagine a simulated experience of that gentle rain. It could be perfect in every detail. The visual information could be flawless, the sound perfectly rendered, the temperature data of each drop precisely calibrated. It could provide your brain with all the information of rain, but it could never provide you with the holistic, unified, and unpredictable experience of actually being in the rain. It cannot replicate the chaotic interplay of all your senses at once, the way the changing light affects the smell of the air, the way the dampness seeps into your clothes, the way the simple act of being there connects you to 1,000 memories of other rainy days. The simulation gives you a perfect map, but the real world gives you the territory in all its messy and glorious imperfection. And so, a quiet and somewhat melancholy question begins to surface. If we gain the ability to experience any reality we choose, to summon any sensation on demand, will we lose our patience for this one? Will we lose our appreciation for the world that is slow, and sometimes inconvenient, and occasionally painful, but that is, and will always be, undeniably and beautifully real? And as we contemplate this potential disconnection from the world outside, we must also turn our gaze inward to the world within. In a state of perfect, seamless connection to everything and everyone, what happens to the beautiful, difficult, and necessary art of being alone? There is a quiet inner room inside you. It is a room that, in all of human history, no one else has ever entered. It is a space of absolute solitude, where your thoughts, in their purest and most unfiltered form, can unfold. What do you find when you take the time to visit this room? Perhaps you find the echoes of the day's conversations, the quiet work of sorting through your memories. Perhaps you find the gentle bubbling up of a new idea, a creative spark that could only ignite in the absence of external noise. Or perhaps you simply find a deep and restorative stillness, a sense of coming home to yourself. This inner world is your ultimate sanctuary, and the ability to retreat into it is one of the most precious gifts of consciousness. But a future of total, seamless connection threatens to dissolve the very walls of this room, to leave us perpetually exposed to the thoughts, feelings, and demands of the outside world. We must, therefore, gently explore the profound value of solitude, which is not the same as the pain of loneliness, but is rather the peaceful, creative, and essential state of simply being with oneself. It is the clarity of thought that arises during a long, solitary walk in a quiet wood. It is the imaginative flight that takes wing while reading a book in a silent room. It is the slow, patient work of building a coherent self, a self that knows its own mind because it has spent time listening to it. This inner work has a direct correlate in the physical architecture of the brain. Neuroscientists have discovered a fascinating network of brain regions known as the default mode network. This network is, rather beautifully, most active when we are not focused on any particular task in the outside world. It is the network that hums to life when we are daydreaming, reflecting on the past, imagining the future, or simply letting our minds wander. It is, in a very real sense, the neurological basis for introspection. The default mode network is where we consolidate our sense of self, where we weave the disparate threads of our experiences into the coherent tapestry of our life's story. Constant stimulation, a perpetual stream of information from an external web, could starve this crucial network. If we are never at rest, if our minds are never allowed to wander freely, we might lose the very mechanism by which we build and maintain our identity. We would be a collection of experiences, but we would not be a self. This leads us to the psychological concept of boundaries, the invisible but essential line that separates me from not me. A healthy psychological boundary allows us to empathize with others without being consumed by them, to love others without losing ourselves in them. A constant, unfiltered connection to the thoughts and feelings of others could erode these boundaries, creating a state of psychic diffusion where it becomes difficult to know where our own feelings end and another's begin. Furthermore, a connection to a global network that, like the internet of today, is designed to remember everything forever, runs counter to one of the most important and least appreciated functions of a healthy biological brain: the ability to forget. Our brains are not designed for perfect, total recall. Forgetting is not a flaw. It is a feature. It is a vital process of pruning, of clearing away the irrelevant, trivial, and painful details of our lives, so that the important memories, the useful skills, and the crucial lessons can stand out in sharper relief. Forgetting allows us to heal from past traumas. It allows us to forgive both others and ourselves. It allows us to move forward, to grow, and to change. To be tethered to a perfect, external memory, an internet that never forgets a single mistake, a single awkward moment, a single painful word, could be a form of psychological torment. It would be like living in a house where the rubbish is never taken out, a home cluttered with the debris of every moment of your past, leaving no clean, open space for the present. As we contemplate this sacred, inner island of the self, and the great digital ocean that threatens to submerge it, we are left with a subtle but piercing question. Is a private thought still truly private if it exists on a network? Even if it is perfectly encrypted, protected in a locked box that only we can open, the mere fact that it has been converted into data that it exists in a space outside of our own skull, that it has the potential to be seen, might change its very nature. We might begin to self-censor our own deepest thoughts, to groom them for an audience that isn't there, to lose that final, ultimate freedom. The freedom to think an ugly, or a strange, or a beautiful thought for ourselves alone. And if the individual self, this precious island, becomes just one node in a vast and interconnected network, it also becomes vulnerable to a new and insidious kind of inequality, a great divide not of wealth or of status, but of consciousness itself. Imagine a world not so different from our own, but with one quiet and profound distinction. It is a world where some people can learn to speak a new language, not in years of study, but in a single, silent moment of download. It is a world where some can master a complex musical instrument by absorbing the muscle memory of a virtuoso, while others must still practice for 10,000 hours. This is the world that might await us on the other side of a brain-computer interface, and it brings with it a question of equality that we have never before had to face. The division would not be one of wealth, or class, or creed, but a chasm that runs through the very heart of human experience itself. The great cognitive divide. Let us try to picture this world not with judgment, but with empathy, through the eyes of two people living in this future. One, let us call her Ilara, is augmented. When she walks through a city, her mind is a symphony of information. She sees the architectural history of the buildings, layered over their physical forms. She hears the conversations of others translated in real time in her mind. She understands the complex economic flows of the marketplace as an intuitive, visual pattern. The world, for her, is a place of infinite depth, clarity, and connection. The other, let us call him Kale, is not augmented. He experiences the world as we do now, with his 5 natural senses. But in this new context, his reality feels muted, slow, and strangely thin. When he speaks with Ilara, he feels as though he is speaking a forgotten dialect, a language of simple, beautiful, but limited words, while she speaks a language of pure, instantaneous meaning. There is no malice between them, but there is a distance, a gap in understanding that no amount of kindness or patience can fully bridge. This division would likely begin, as most technological revolutions do, as a simple matter of economics. The first brain-computer interfaces, especially those that offer significant cognitive enhancement, will inevitably be fantastically expensive. They will be accessible only to the very wealthy, to corporations, to governments. This would immediately create a new and powerful class system, a cognitive elite whose enhanced abilities would allow them to outthink, outmaneuver, and outcreate the rest of humanity at every turn. The gap between the connected and the unconnected would be greater than any social or economic disparity that has ever existed, and this gap would be unlikely to shrink over time. In fact, it would probably grow, and at an ever-increasing speed. There is a sociological principle known as the Matthew effect, which takes its name from a biblical passage and is often summarized as the rich get richer and the poor get poorer. In this context, those who could afford the first generation of cognitive enhancements would be in the perfect position to invent, design, and profit from the second, even more powerful generation of enhancements, accelerating their advantages exponentially. The rest of humanity would be left further and further behind, not through any fault of their own, but simply because the very pace of progress would have left them behind. And yet, as we contemplate this unsettling vision, we must be careful not to fall into a simple trap. We must challenge the underlying assumption that more or faster information processing is inherently better or constitutes a superior form of intelligence. Is a person who can access every fact in an encyclopedia truly wiser than a person who has deeply contemplated a single, beautiful poem? The qualities that we often value most in human beings, wisdom, creativity, compassion, emotional intelligence, a sense of humor, are not simply a matter of processing speed or data access. They are the slow-cooked fruits of a lifetime of embodied experience, of trial and error, of love and loss, of stillness and reflection. It is entirely possible that an unaugmented mind, in its beautiful and necessary slowness, might preserve certain qualities of thought, certain depths of feeling, that an augmented mind, in its rush of perfect information, might lose. Perhaps the very limitations of our biological brains, our forgetfulness, our biases, our emotional turmoil, are not flaws to be engineered away, but are an essential part of the algorithm that produces wisdom. This possibility presents us with a profound ethical choice for the future of our species. What is our responsibility to each other in the face of such a potentially divisive technology? Do we embrace a form of technological egalitarianism and declare that cognitive enhancement is a basic human right, a utility that must be provided to all, perhaps even mandated for all, to ensure no one is left behind? Or do we take the opposite path? Do we champion cognitive liberty, the fundamental right of an individual to choose to remain exactly as they are, to protect the unaugmented, natural human mind as a thing of intrinsic and incalculable value? There is no easy answer, and this great question of choice, of whether to cross the cognitive divide, leads us to an even deeper, more unsettling possibility. What if, in the end, the choice is not entirely our own? Imagine a thought that isn't yours. It doesn't arrive like a thunderclap or a foreign voice. It doesn't feel like an invasion. Instead, it appears at the edge of your consciousness as a gentle suggestion, a subtle nudge, a quiet whisper that feels, in every essential way, like your own. How would you ever know it was planted there? How could you distinguish an idea that was seeded by an external source from one that has blossomed organically from the soil of your own mind? This is the whisper of control, the most subtle and perhaps the most pervasive peril of a mind that is constantly listening to an external web. It is a danger that does not announce itself with force, but with a seductive and melancholic quietness. To understand its power, let us trace the path of such a thought. Imagine an idea, perhaps a preference for a certain product, or a slight shift in political opinion, is introduced into your mind stream. At first, it feels alien. You might dismiss it. But the system is patient. It shows you the idea again, perhaps framed in a slightly different way, associated with a pleasant feeling, a warm colour, a soothing sound. It is echoed by the other thoughts you encounter on the network. Slowly, imperceptibly, the idea loses its foreignness. It becomes familiar. It becomes comfortable. And one day, you find yourself expressing this idea to a friend, not as something you heard, but as a deep and undeniable truth that you feel you have discovered for yourself. The seed has taken root, and you have mistaken the vine for a part of the tree. This is not a far-fetched dystopian fantasy. It is merely the ultimate extension of a science that is already well established today. The fields of advertising and marketing have for decades been perfecting the art of neuromarketing, the science of influencing consumer behavior by appealing to subconscious triggers that we are not even aware of. Every color in a logo, every camera angle in a commercial, every note of music in a store is often carefully chosen to bypass our rational mind and speak directly to our deeper, more primitive desires and fears. A direct brain-computer interface could make this process of persuasion infinitely more precise and powerful. It could monitor your emotional state in real time and deliver a perfectly tailored suggestion at the exact moment you are most receptive to it. It could shape your desires before they even surface into your conscious awareness, making you crave a product you never knew you wanted, or fear a person you have no rational reason to dislike. The control would be so seamless that it would feel like freedom. This process is a high-tech version of a core principle of behavioral psychology known as operant conditioning. The idea that behavior can be shaped through a system of rewards and punishments. A connected mind could be trained by a network that provides a tiny, imperceptible reward, a little pulse of pleasure, a microscopic release of dopamine for thoughts and actions that are considered desirable or compliant. Conversely, it could subtly withhold that sense of pleasure for thoughts that are dissenting or disruptive. Over time, our very thought processes would be gently guided, like a river being coaxed into a new channel, toward the path of least resistance, the path of greatest reward. The most chilling aspect of this kind of control is that it would not require a single, central, all-powerful villain to implement it. It could be an emergent property of a complex system. There is a concept in physics and complexity science known as emergent order. You can see it when you watch a crystal form in a chemical solution. There is no blueprint, no leader. Each individual molecule simply follows a very simple set of local rules, aligning itself with its immediate neighbors. And from these millions of simple, local interactions, a large-scale structure of breathtaking complexity and order, the crystal emerges as if by magic. In the same way, one could imagine a network where millions of individual minds are subjected to a few simple, local rules, a few subtle, algorithmically determined nudges. The goal might not even be overtly malicious. It could be something as seemingly benign as increasing social harmony or promoting economic growth. But the result of these millions of tiny, imperceptible nudges could be the emergence of massive, predictable, and highly organized social and political movements, all while each individual person within that movement feels that they are acting entirely on their own, a heroic champion of their own freely chosen beliefs. And so we are left with a question that cuts to the very core of what it means to be human. If our free will can be so easily and so invisibly guided, is it truly free? If the landscape of our mind can be so subtly sculpted by an external architect, where does the authentic self end and the gentle influence begin? We pride ourselves on our autonomy, on our capacity for reason and independent thought. But what if that independence is merely a beautiful story we tell ourselves? A ghost in a machine whose gears are being turned by a silent, unseen hand. The prospect of changing a mind is a profound one, but it pales in comparison to an even more audacious and terrifying possibility. The power not just to influence a mind, but to create it from the very beginning. Look, in your mind's eye, at the face of a newborn baby. See the universe of pure, quiet potential in their eyes. Their mind is a new and beautiful book, its pages pristine and unmarked, waiting for the story of a life to be written upon them. As a parent, a caregiver, a fellow human being, you feel an almost overwhelming sense of awe and responsibility in the presence of this new consciousness. You project onto this tiny being all of your highest hopes, your deepest dreams, and your most secret fears. You feel a profound and instinctual desire to give them the best possible start, to equip them with all the tools they will need to navigate the beautiful and difficult journey of life, to protect them from the pain you have known, and to provide them with the wisdom you have so painstakingly acquired. This deep, loving impulse to shape and guide a new life is one of the most noble aspects of our humanity. But a technology that can interface directly with the brain takes this impulse into a realm of staggering power and moral complexity. It raises the possibility of not just guiding the hand that writes the story, but of printing the first few chapters onto the pages before the book is even opened. To understand how this might be possible, we need to gently touch upon the beautiful dance between genetics and epigenetics. We often think of our DNA as a fixed blueprint, a set of unchangeable instructions for building a life. But this is only half the story. Above the genome, there is the epigenome, a complex system of chemical markers that act like the builder's notes on the blueprint. These epigenetic markers tell our genes whether to switch on or off, whether to express themselves loudly or to remain silent. And crucially, these markers are not fixed. They can be influenced by environmental factors, by nutrition, by stress, by experience. It is the reason why identical twins, who share the exact same genetic blueprint, can grow into very different people. A direct brain interface could, in theory, influence this delicate process during the critical stages of brain development. It could send signals that encourage certain neural pathways to form and discourage others, effectively writing epigenetic notes that could shape the very foundation of a child's temperament, talents, and personality. This would be happening during the most sacred and important time in human development, the critical periods of early childhood. This is the window of time when the brain is astonishingly plastic, when experiences with caregivers and the environment literally shape the physical architecture of the mind, laying down the foundations for language, emotion, and social connection for a lifetime. This technological potential pushes us into a realm that has, until now, belonged only to philosophy. Philosophers have long debated the concept of a priori knowledge, the idea that some knowledge might be innate, something we are born with rather than learn through experience. A brain-computer interface could transform this from a philosophical debate into a technological reality. Could we, and should we, install the fundamentals of language into a developing brain so that a child is born with a perfect grasp of grammar and vocabulary? Could we install the axioms of mathematics, the principles of logic, the vast and beautiful history of art? Could we, in our most audacious moment, attempt to install the foundations of morality, a framework for kindness and compassion, into the very blueprint of a soul? We could imagine a world where we have eliminated the long, frustrating, and difficult struggle of learning, where every child begins their life with a foundation of knowledge that took humanity millennia to accumulate. We could, in theory, engineer a generation of beings who are healthier, smarter, and perhaps even kinder than we could ever be. And as we stand before this vision, this awesome and terrifying power to become the architects of the human soul, we must pause in the deepest and most humble silence. We must ask ourselves the most difficult questions. Do we have the right to write in the books of our children? What is the real, functional difference between good parenting and gentle, loving programming? We all want to remove unnecessary suffering from our children's lives, but is the struggle of learning truly unnecessary? Is it not in the falling down that we learn to walk? Is it not in the frustration of a difficult problem that we discover the joy of insight? Is it not in the messy, imperfect, and often painful process of becoming that we develop resilience, character, and wisdom? By removing the struggle, do we risk creating a beautiful, perfect, but fragile being, a masterpiece of engineering that has never learned the simple, vital strength that comes from having to build itself? These questions take us to the very edge of what it means to be human, and they are so immense, so consequential, that they force us to look up, away from ourselves, and out into the vast, silent cosmos, and to ask a simple, lonely question. Are we the only ones who have ever had to face such a choice? Listen. In the space between the stars, in the vast, cold, and beautiful emptiness of the cosmos, there is a profound and unsettling silence. Our telescopes have become impossibly powerful, our listening devices exquisitely sensitive. We have been straining our ears, listening to the heavens for over half a century. And in all that time, from all the billions upon billions of stars in our galaxy, we have heard nothing. Not a whisper, not a signal, not a single solitary sign that we are not alone. And so, we must ask the question that has haunted astronomers and philosophers for decades. Where is everybody? This is the heart of what is known as the Fermi paradox, and it casts a long, cosmic shadow over our entire human story. Let us, for a moment, drift away from our world and feel the true scale of this silence. We float past our moon, a silent, pockmarked companion. We pass the glowing embers of Mars and the swirling, majestic storms of Jupiter. Our solar system shrinks behind us until it is just another spark in the immense, glittering river of the Milky Way galaxy, a city of 400 billion stars. And then we drift further, out into the intergalactic void, and we see that our galaxy is but one island of light in a cosmic ocean filled with trillions of other galaxies, each one home to billions upon billions of stars, and presumably countless planets. The numbers are so large they become meaningless, a hymn to the infinite. And yet, from all of that, there is only silence. The Fermi paradox is so powerful because of the stark contradiction it presents. On the one hand, the sheer number of planets that could potentially harbour life in the universe is staggeringly high. The probability seems to suggest that the cosmos should be teeming with civilizations, many of them millions of years older and far more advanced than our own. And yet, on the other hand, we have precisely zero evidence of their existence. There are many proposed solutions to this paradox, but one of the most haunting is the idea of the Great Filter. This concept suggests that there is some barrier, some immense challenge or danger that lies on the path of any developing civilization, and that it is a filter through which very few, or perhaps none, ever pass. This filter could be anywhere on the timeline. Perhaps life itself is incredibly rare. Perhaps the leap to complex, multicellular life is the filter. But perhaps the filter lies ahead of us. Perhaps every advanced civilization eventually discovers a technology so powerful that it inevitably leads to its own self-destruction. And one cannot help but wonder if the invention of a global brain-computer interface, the moment a species links its consciousness into a single, unified web, might be precisely such a filter. It could be the point of ultimate transcendence, the moment a species sheds its individuality and becomes a galactic superorganism. Or it could be the point of ultimate collapse, a descent into conflict, information overload, or a loss of the will to survive. A final, quiet fade into the great cosmic silence. This silence is also enforced by one of the most fundamental and beautiful laws of our universe, the absolute, unbreakable speed limit of light. As described by Albert Einstein's theory of relativity, nothing in the cosmos can travel faster than light. And while the speed of light is incredibly fast from our human perspective, about 300,000 kilometers per second, the distances between stars are so mind-bogglingly vast that this speed limit becomes a profound form of cosmic isolation. A radio message sent to our very nearest neighboring star, Proxima Centauri, would take more than 4 years to arrive. A conversation would be impossible. To send a message to the other side of our own galaxy would take 100,000 years. This immense latency makes a real-time galactic internet, like the one we are imagining for Earth, a physical impossibility. The universe, by its very nature, enforces a beautiful and perhaps tragic solitude upon every world. Every civilization is, in a sense, an island, forever separated by an uncrossable ocean of space-time. We can shout into the void, but the echoes will take lifetimes to return. And as we float here, in this immense and silent cathedral of stars, perhaps we can imagine another, more hopeful solution to the paradox. Perhaps the great silence is not empty. Perhaps it is simply quiet. Perhaps it is the nature of all mature, wise civilizations to eventually discover that the universe within the mind is just as vast, just as complex, and just as beautiful as the universe of stars and galaxies outside. Perhaps, having explored their outer world, they turn their great journey inward, into the boundless landscapes of consciousness. It is a comforting thought, a vision of a cosmos not empty, but filled with silent, dreaming minds. And this thought leads us back to ourselves, to our own small, noisy, and beautifully hopeful world. What if we were to broadcast our own newly connected consciousness into that great silence? What song would we choose to sing? What message would we send in a bottle? Cast out into that dark and silent sea. If you could choose one single memory, one quintessential feeling from the entirety of your life, and send it out into the cosmos to drift for 1 billion years among the silent stars, what would you choose? Would it be a moment of great joy, the peak of a magnificent vista after a long climb? Would it be a moment of profound love, the quiet and certain knowledge of being perfectly understood by another? Or would you perhaps choose a moment of sorrow, a feeling of loss, to communicate that our existence, for all its beauty, is also tinged with a deep and poignant fragility? This desire to be known, to be remembered, to send a piece of ourselves out into the great, silent darkness, is one of the most ancient and deeply human impulses. It is the impulse that drew pictures on cave walls, that built the pyramids, and that, in the year 1977, led us to send the most beautiful message in a bottle that humanity has ever conceived. That year, 2 small spacecraft, Voyager 1 and Voyager 2, were launched on a grand tour of the outer planets and, eventually, into the vast, unknown territory of interstellar space. And attached to the side of each of these tiny, lonely vessels is a golden record. On this record, we encoded the sounds of our world, a mixtape for the cosmos. There is the sound of the wind and the rain and the crashing of ocean waves. There is the cry of a newborn baby and the sound of a mother's first words to her child, the sound of her kiss. And there is our music, the soaring, mathematical perfection of Bach, the deep, earthy blues of blind Willie Johnson, and the exuberant, youthful joy of Chuck Berry. It was a gesture of immense and irrational hope, a testament that on this small, blue world, in our brief and fleeting moment of existence, we lived, and we felt, and we made beautiful things. The creation of this golden record was an extraordinary challenge in the art of translation. The scientists, led by the visionary Carl Sagan, had to assume that any alien intelligence who might one day find this record would have nothing in common with us. No shared biology, no shared culture, no shared language. So, how do you create a message that can be understood? The solution was to use the one language that we must surely share with any technological civilization: the language of physics. The instructions for how to play the record, how fast it should be spun, and how to decode the images also stored on it, were all given in a diagram that uses the fundamental properties of the hydrogen atom as a universal Rosetta Stone. Hydrogen is the most abundant element in the universe, and its properties are the same everywhere. It was a breathtakingly clever attempt to bridge the unimaginable gap between two completely alien minds, a message of greeting written in the very laws of the cosmos itself. This message is now traveling on a journey of almost unimaginable length. And because of the strange and beautiful nature of time, as described by Einstein's theory of relativity, the message is, in a sense, a traveler to the distant future. As an object approaches the speed of light, time itself begins to slow down for it relative to the rest of the universe. The Voyager spacecraft are not traveling anywhere near that speed, but their journey reminds us of this principle. A message sent out into the cosmos is a letter addressed not just to a distant place, but to a distant time. It is our voice, echoing into the far future of the universe. Now, imagine if we could compose such a message not with the clumsy tools of sound waves and pictures, but with the direct language of the mind itself. What would a mental golden record contain? A fully developed brain-computer interface could, in theory, allow us to compose a message that is not a description of an experience, but the experience itself. We could create a compressed packet of pure qualia, the raw feelings that make up our inner world. We could send not the sound of laughter, but the feeling of joy itself. We could send not a mathematical equation describing curiosity, but the pure, inquisitive, electric idea of curiosity. We could send the direct, unmediated, subjective experience of seeing the color green for the very first time. This would be the ultimate message in a bottle containing not just a story about the light, but a tiny, captured piece of the light itself, the very essence of our consciousness. And as we imagine composing this ultimate message, this distillation of all that we are forced to confront that same beautifully difficult question we began with. What is the single most important thing about humanity that we would want another mind, another form of consciousness, to understand? Is it our incredible capacity for logic and science? Is it our creation of art and music? Is it our ability to feel love and empathy for one another? Or is it something quieter, something more complex? Perhaps it is our very imperfection, our capacity for sorrow, our knowledge of our own mortality, that gives our existence its meaning and its beauty. The act of sending a message is an act of profound hope, but it implies a second act, the possibility of one day receiving one. And the act of listening, of opening a bottle that has washed up on our shore from a distant and unknown sea, would change everything. It suggests that the final choice we must face is not just about what we choose to become, but about how we choose to listen. Imagine you are an archaeologist, exploring a ruin that has been sealed for 10,000 years. In the heart of a hidden chamber, you find a single, exquisitely crafted manuscript. It is written in a language you have never seen, its script flowing and beautiful, utterly alien. The manuscript is sealed with a lock of intricate and unfamiliar design. You feel a burning, all-consuming curiosity. What secrets does this ancient book contain? The history of a lost civilization, a forgotten science, the answers to the deepest questions of existence. Your every instinct is to break the seal, to force the lock, to open the book and gaze upon its contents. But then, a quieter, more cautious voice whispers in your mind. This vessel, this book, is as much a part of the message as the text inside. By forcing it open, you might destroy something vital. Perhaps the lock itself is a key to the language. Perhaps the way you open the book determines what story it tells you. Perhaps the wisest course of action is not to open it at all, but to wait, to study the vessel, to learn its context, and to approach it with a patience and a humility that is equal to its mystery. This is the ethical dilemma we face with the prospect of a brain-computer interface. We have found a sealed book, and we are faced with the profound choice between our desire to know and the wisdom of caution. As we hold this fragile and unknown technology in our hands, we can be guided by a humble and powerful ethical framework known as the precautionary principle. In its simplest form, this principle states that if an action or a policy has a suspected risk of causing severe and irreversible harm to the public or to the environment, and if there is no scientific consensus that the action is harmless, then the burden of proof falls on those who are proposing to take the action. In other words, it is not up to the public to prove that a brain net is dangerous. It is up to its creators to prove, beyond a reasonable doubt, that it is safe. It is an instruction to pause in the face of uncertainty, to favor caution over recklessness, and to remember that the consequences of our actions may ripple out in ways we cannot yet predict. It asks us to respect the complexity of the system we are proposing to alter in this case, the human mind, the most complex system in the known universe. The challenge of creating a safe and ethical framework for a powerful new intelligence is one of the most difficult tasks we can imagine. The great science fiction writer Isaac Asimov famously explored this in his stories with his 3 laws of robotics, a set of rules designed to ensure that artificial intelligences would always remain beneficial to humanity. The fascinating thing about Asimov's stories is not that the laws work perfectly, but that they almost always fail in strange and unexpected ways. The stories are not a blueprint for AI safety. They are a series of brilliant cautionary tales about the difficulty of predicting the consequences of even the simplest and most well-intentioned rules when they are placed in a complex system. The attempt to write a simple, foolproof ethical code for a superintelligence, or for a globally connected human consciousness, is likely a fool's errand. The world is too complex, too messy, too unpredictable. This does not mean we should not try. It means we must try with a profound sense of humility. And we must also face a sobering reality. Some technological doors, once they are opened, can never be closed again. The invention of nuclear energy, for example, is a piece of knowledge that humanity can never unlearn. A fully integrated, global brain-computer interface might be just such a technology. The decision to cross that threshold, to fully merge our minds with our machines, would be an irreversible one. It would not be a decision made for one generation, but a choice made for every single human being who will ever exist in the future. And so, as we stand before this sealed manuscript, this profound and alluring possibility, we must ask ourselves, can we ever be wise enough to wield such a tool? Do we possess the foresight, the humility, the collective compassion to navigate its perils? Or is the very attempt to gain ultimate knowledge, ultimate connection, ultimate control, the final and greatest act of human hubris, the very filter that explains the great silence in the stars? The questions are vast, cosmic, and almost paralyzing in their weight. And it is at this very moment, when we are lost in the largest possible scales of time and space, that we must remember to gently bring our attention back from the distant future, back from the silent galaxies, and back to the quiet, humble, and hopeful present. The path forward begins not with a single, grand, and terrifying leap, but with a single, small, and profoundly human step. After such a long and winding journey through the vast landscapes of the future, through shimmering forests and silent galaxies, it is time for us to gently return home. Let us bring our attention back from the distant horizon of what might be, to the quiet, humble, and profoundly hopeful reality of what already is. To do this, I want you to imagine, with the deepest empathy you can summon, what it might be like to be locked inside your own body. Imagine your mind is as sharp, as vibrant, as alive as it has ever been. Your memories are intact, your wit is undimmed, your love for your family burns as brightly as ever. But the connection between your mind and your body has been severed. You cannot move. You cannot speak. You cannot even blink to signal your presence. You are a ghost in your own machine, a silent, unseen witness to the world. Now, imagine, after years of this profound and total isolation, someone offers you a key. a key that can unlock a single tiny window from your silent prison to the world outside. This is not science fiction. This is the gentle, dawning reality of brain-computer interfaces today. And it is here that we find the technology's most undeniable and beautiful promise. Let us immerse ourselves for a moment in the inner world of someone living with this condition, often called locked-in syndrome. Their mind is a rich and vibrant place, a secret garden that no one else can see. And then, one day, scientists and doctors place a small sensor on their head, a device that can listen to the faint electrical whispers of their brain. They are asked to simply think about moving a cursor on a screen to the left or to the right. It is a monumental effort of concentration. And then, a miracle. The cursor, for the first time, flickers. It moves. A connection has been made. A voice, silent for so long, has found a way to speak. The first message, slowly and painstakingly typed out letter by letter, might be a simple hello. Or it might be I love you. The profound, earth-shattering relief, the sheer, unadulterated joy of that first moment of reconnection is the true heart of this technology. We are already seeing people with paralysis use their thoughts to control sophisticated robotic arms, to pick up a cup of coffee and bring it to their own lips for the first time in decades. We are seeing these interfaces restore a sense of touch, sending signals from a prosthetic hand back to the brain so that a person can feel the texture of a loved one's skin once more. This is where the work is happening, not in creating superintelligence, but in performing small, patient miracles of restoration. And this healing touch extends beyond paralysis. Non-invasive technologies like the EEG, the gentle method of listening from outside the concert hall, are being used in remarkable ways to help people with conditions that affect the mind itself. There is a field called neurofeedback, which you can think of as learning to tune the instrument of your own mind. A person sits with an EEG cap on, and they watch a simple representation of their own brainwave activity on a screen. Perhaps it is the color of a circle or the sound of a musical note. They are then gently instructed, through a process of trial and error and quiet focus, to change that color, to alter that note, by consciously altering their own mental state. Over time, people can learn to regulate their own brainwaves, to calm the patterns associated with anxiety, or to focus the patterns that are often scattered in conditions like ADHD. It is a way of giving people direct, intuitive control over their own inner world, a non-chemical path toward balance and well-being. And it reminds us that the grand future we have been contemplating will not arrive overnight in a sudden, dramatic flash. Science moves slowly. It is a process of decades of small, careful, incremental steps, each one tested and retested and debated. The journey to a connected consciousness will be a long and winding road, and every single step of that road, for the foreseeable future, will be paved with the intention to heal, to repair, and to restore. And so, perhaps this is the most beautiful and grounding reflection of all. Perhaps the true promise of this technology, in our lifetime and in the lifetime of our children, is not to become more than human. It is not to transcend our biology or to become gods of information. It is something far more humble and far more profound. It is the promise of becoming fully human again. It is the promise of giving a voice back to the voiceless, of giving movement back to the paralyzed, of restoring a sense of peace to a troubled mind. It is a technology not of enhancement, but of wholeness. And as we sit with this gentle, hopeful thought, we can feel ourselves arriving back at the very beginning of our journey, back in the quiet and familiar landscape of our own minds, listening to the gentle, rhythmic hum of our own consciousness, here and now, on the cusp of a new morning. The glowing screen you hold in your hand, or the one that may be sitting in the room with you now, connects you to a vast and miraculous world of information. With a simple touch, you can access the collected knowledge of our species. You can speak to a loved one on the other side of the planet. You can lose yourself in stories of unimaginable beauty. But what happens when you put it down? What do you connect to when you turn off the screen and simply look up? You connect to the gentle, quiet, and unfiltered reality of the present moment. This is the final and perhaps most important destination on our long journey tonight. The here and now. Let us end, Then, with a simple and grounding sensory experience, feel, for a moment, the physical reality of this space around you. Feel the weight of the blanket or the coolness of the sheets against your skin. Feel the gentle pressure of your head on the pillow. Listen to the quiet sounds of your environment, the distant hum of the sleeping city, the soft whisper of the wind outside, the slow, steady, and reassuring rhythm of your own breathing. This, too, is a form of connection, a plugging into the most profound and fundamental network of all, the network of being. Throughout our journey, we have talked about the brain and the internet as two separate things that might one day be connected. But it is also helpful to remember that we already possess, within our own skulls, the most powerful, most complex, and most beautiful network in the known universe. Our human brain is the original World Wide Web. Its bandwidth is the rich, slow, and nuanced stream of language. Its protocols are the unspoken rules of a gentle touch, a knowing glance, an empathetic ear. It connects us to each other, not with the speed of light, but with the slow, steady, and deeply resonant speed of love, of trust, and of shared experience. And it connects us to the cosmos through our senses, through the ancient starlight that falls upon our retinas, through the air molecules that carry the scent of the rain, through the gravitational pull of the earth that holds us safely in its embrace. The choice we face, then, is not simply about whether or not to adopt a new technology. It is a much deeper choice about how we wish to live and what we choose to value. Our attention is our most precious and finite resource. Where we choose to place it is the act that creates our reality. Every technology we build, from the simplest book to the most complex neural interface, is a competition for this attention. And so, we can find a quiet power in the philosophy of what is sometimes called the slow tech movement. It is a gentle counter-narrative to the relentless rush for more speed, more connection, more information. It is the idea that we can and should mindfully choose the technologies that serve our deepest human values, and quietly set aside the ones that subvert them. It is the wisdom of choosing to read a physical book because it offers a space of quiet, focused contemplation. It is the choice to have a face-to-face conversation with all its awkward pauses and beautiful imperfections, because it creates a bond that no digital text can replicate. It is the simple, radical act of putting down the phone, of turning off the screen, and of choosing to connect with the person right in front of you, with the natural world around you, or, most importantly, with the quiet, waiting stillness of your own mind. The future is not a fixed destination that we are hurtling towards. It is not a story that has already been written. It is a path that we are creating, all of us together, with every small choice we make every single day. The decision to plug our brain into the internet will not be a single, dramatic event. It will be a slow cascade of a million tiny decisions. The apps we choose to use, the notifications we choose to enable, the balance we choose to strike between our digital and our physical lives. The promise or the peril lies not in the wire, but in the will that guides it. It lies in our wisdom, our compassion, and our ability to remember what truly matters. Thank you for taking this long and gentle journey with me tonight. I hope it has been a source of wonder, of comfort, and perhaps even of a little peace. I would love to read your own gentle reflections in the comments below. And if you have found some quiet companionship in our time together, please do consider liking this video and subscribing to the channel. For now, there is nothing left to do but to let these ideas dissolve, to feel the gentle pull of sleep, and to rest. May you have the sweetest and most peaceful of dreams.